Good morning, students. We will continue with our exercise 7.3 that we started in the previous class. And in the previous class, I asked you people to try sums till sum number 10. We will start with sum number 11 here. So, sum number 11 is we have to find the integral of cos raised to power 4 2x dx. Now cos, that means the power of function is 4 and the angle is given here 2x, and once again we don't have any formula to do the integration straightforward of this function. So what we will do here, we will start simplifying the function. I can write it as cos 2 or cos square 2x whole square dx. Why we are doing this thing? First, because 4 power is there, so I can write it as 2 raised to power 2, and we know cos square identity. We have used this identity till now many times, and if you remember what was the identity here, we have done here cos 2a is equals to 2 cos square a minus 1, which implies cos square a can be written as 1 plus cos 2a whole divided by 2. So now we have this identity. If I have square of cos, I can convert it into linear, right? So that is why we are doing this thing. So based upon this formula, what we will do, we will write down this cos square 2x. Now the angle A is 2x, and here what will happen, the angle is getting double. So when I apply this formula, the angle 2x here, when I write down, it will become 4x. So what we are getting here, we'll write here 1 plus cos 2 into 2x whole divided by 2, and we have the square of this function. As we have the power 2, we have just applied the identity over this, right? So now when I square it, this 1 by 4 we can take outside since it is constant, and 1 plus cos 4x a plus b whole square formula, if I apply, we will get 1 plus cos square 4x plus 2 cos 4x dx. That means a square plus b square. Now the square of cos 4x will be cos square 4x, that means the function will get squared, not the angle, into 2 cos into 2ab, so 2 into cos 4x. Now 1 by 4 is there, integral, and here we have the first term 1, the second is again square of, so once again we will apply the same identity over this term. So let us apply the identity. Now the value of a is 4x, so when I apply the identity for this term, when I double the angle, it will become 8x. So here we are getting 1 plus cos 8x divided by 2. This function we are writing this way, plus 2 cos 4x will remain as such. So now this is our function, simplified function. Okay, so when we do the integration 1 by 4 as such, the integral of 1 will be x plus this 1 by 2 is there, so the integral of 1 by 2 will be x by 2 plus this 1 by 2 is constant as such, integral of cos is sine, angle no change in angle, divided by derivative of angle 8 will come, plus this 2 is as such. Okay, and the integration of cos will be sine 4x divided by derivative of the power bracket closed plus constant of integration. So when we simplify, what we are getting here, this x plus x by 2 means 3x by 2, so we are getting here 3x by 8 plus 8 into 2 into 4, 4 into 2 is 8, 8 into 8 is 64, so sine 8x divided by 64 plus this 1 2 will get cancelled here, and we are getting sine 4x divided by 8 plus constant of integration will be our answer. So this is how, as if we are having the powers of our trigo functions and we don't know the direct integration, don't know means there is no formula for the integration of those powers of trigo functions, so we will use our trigo identities to simplify the function, and then we are doing the integration, right? So if you people were having the doubt in sum number 10, so sum number 10 also we will be doing the same way. Instead of this cos raised to power 4, we have sin raised to power 4x. The angle is x only, so we will write down sin square x whole square, and then sin square x can be written here 1 plus cos, so sin square x will be written 1 minus cos 2x by 2, right? Likewise you people can complete that. And sum number 12 is sine square. So let me give you the hint for that. Sum number 12, sum number 12, we have integral of sine square x whole divided by 1 plus cos x dx. Now 1 plus cos x is there, and this sine square x, we have to just make the relationship between the functions of numerator and denominator so that the functions can be simplified. If you notice, the angles are same. Here we have square of the function, but this function is linear. So now let me write down one thing here. If I know the formula of sine 2a, what is that formula? It is 2 sine a cos a, right? And the next formula, if you remember, 1 plus cos 2a, that formula is written as 2 cos square a, right? So what we are going to do here also, angle double, angle is reduced to half, angle is reduced to half, and here I have x angle, it means if I want to apply this formula, I can do that. Now the only thing is here I have sine square x, and if you know, I can write this thing as sine x whole square divided by this 1 plus cos x. If you want, I can use this formula here. 1 plus cos x will become 2 cos square half of the angle x by 2 dx. Okay, so now this 2 is I can take outside. Now I want to make this sin x. If you notice here, sin 2a is 2 sin a cos a. So instead of 2a angle, if my angle is x, then this formula will become 2 sin x by 2 cos x by 2 whole square divided by 2 cos square x by 2 dx. Now once again, when I applied these two identities in the numerator and denominator, angles are again x by 2, x by 2. Equal angles are there. It means we can solve or we can simplify the function. So when I take this 2 outside, 1 2 will get cancelled, 1 2 we can write down outside, and we have sine square x by 2 into cos square x by 2 whole divided by cos square x by 2 dx. Right, that means we are getting 2 sine square x by 2 dx. Now 2 sine square x by 2 dx, and once again I am writing the formula. Cos 2a is 1 minus 2 sine square a. That means 2 sine square a can be 1 minus cos 2a. Now this 2 if I bring here, I am getting 2 sine square x by 2, so which can be written as 1 minus cos double of angle. If this is angle A, here I am getting double of the angle, so x by 2 double of the angle will become x, and this is dx, right? And now the angle or the function which we were supposed to integrate is thoroughly simplified, and we are getting 1 minus cos x, and we know the integration of 1 will be x, integration of cos is sin x, plus constant of integration will be our answer. So this is how we will do sum number 12, right? And sum number 9 also I told you people, I hope you people have done. There also we are using the similar kind of identities. Okay, and now we will move to sum number 13, and so sum number 13 is here we have to integrate. Here we have cos 2x minus cos 2 alpha divided by cos x minus cos alpha dx. Now here what is the problem? In the numerator angle is 2x and 2 alpha. In the denominator angle is x and alpha. So we have to simplify the function. We know we have this formula. If the same formula I tell you here in terms of cos, we know if I have 1 plus cos 2a, that means double angle is there, and when I am applying the formula I am getting half of the angle, whatever angle is here. So I can say that cos 2x, this cos 2x can be written as 2 cos square x minus 1, and cos 2 alpha then can be written as 2 cos square alpha minus 1. Let us see how we will apply the formula here. The same formula I am going to apply. This cos 2 alpha can be written as 2 cos square x minus 1 minus, and this cos 2 x we have written this way, and cos 2 alpha can be written then 2 cos square alpha minus 1 whole divided by this we have cos x minus cos alpha dx. Now when I open the brackets, this 2 and this 2 we can bring it outside. Minus 1 minus minus plus. So minus 1 plus 1 they will get cancelled. And what is left? We will be left with cos square x minus cos square alpha. So a square minus b square formula if we apply, the function will be simplified. And let us see what happens in the next step. So what we are left with, this 2 we will write down outside, and here we have cos square x minus cos square alpha upon there is no change in the denominator, cos alpha minus cos x dx. Now here we can apply a square minus b square formula, and when I apply a square minus b square formula, cos x minus cos alpha into cos x plus cos alpha, so one term will get cancelled with the denominator and we will be left with cos x plus cos alpha dx. Now here if you notice, cos x, the variable is x, which is the variable of integration. Alpha is there, it is constant. So this cos alpha is a constant term. Alpha, if I say, if instead of alpha, if it is given like pi or pi by 2 or pi by 3, that means this alpha is fixed. It can be any value, but it is fixed value. So it cos alpha term we have to take it constant, and when we do the integration, we know the integration of cos x is sin x plus this cos alpha is constant, it will come as such, into integration of 1 x will come plus constant of integration. So this will be our answer. Remember, this x is not getting multiplied with the angle. If you want, we can rewrite it. It will become 2 sin x plus 2x cos alpha plus constant. This will be our final answer. Okay, so this is how sum number 13 will be done, and sum number 14, cos x minus sin x upon 1 plus sin 2x, you people can do. Okay, sum number 15 we will try here. Sum number 15 is integral we have to find of tan cube of 2x into secant 2x. Okay, angles are given equal dx. Now we know the relationship between tan and secant. What is the relationship? That the derivative of tan is secant square x. It means from this tan cube, if I take out one more secant, I can get secant square, and when I make the substitution of tan as y or t, secant square can come as the derivative, right? So what we will do, we will write this, or we will use the identity which is having tan function and secant function. So for that, what I am going to write here, I will write it as tan square of 2x into tan of, okay, sorry, there was some disturbance. So tan square 2x into tan 2x, and this secant 2x dx we are writing. Now we know this tan square 2x can be written as secant square 2x minus 1, and here we are writing tan 2x secant 2x dx, right? Now this term which is in the bracket, it will get multiplied with both the terms. So let us simplify this, what we are getting here, we will get here tan 2x into secant cube 2x dx minus tan 2x secant 2x dx. Right? Now here we have tan 2x secant cube 2x dx. So what we will do here, we know the derivative of tan is secant square, and we also know the derivative of secant x is secant x tan x. Right? I hope everybody remember the formulas of differentiation, and we know, I'm repeating, we know the derivative of tan is secant square. So if I put here tan as y, it is not secant square, so 1 secant 2 will be left. That we can't do. But if I write 1 secant like with this tan, and 1 secant square will be left separate, then what we can do here, I can put the secant function as y, because we know if I differentiate secant function, what is the derivative? The derivative of secant is secant x tan x. That means if I differentiate with respect to x. So let us separate the terms like that only. We will club the terms secant x tan secant 2x tan 2x here, and here secant square 2x dx, this is one integral, minus the other integral is secant 2x tan 2x dx. Now we know the derivative of secant x is secant x tan x. It means the antiderivative of secant x tan x will be secant x. In short, the integral of secant 2x tan 2x, what will be that? It will be secant 2x. Right? And here if I know the derivative of secant x tan x is, I know the derivative of secant x is secant x tan x. So we will substitute this function there. So if you want, I can mark it as I1, and this we can mark it as I2. There will be two integrals which we will integrate turn by turn. So the first integral that we are going to solve here, it is I1, and here we are writing secant 2x square into secant 2x tan 2x dx. Right? So what we will do here, we will put here secant 2x as y, and when we differentiate both sides, we will get here secant 2x tan 2x into derivative of the angle equals to dy by dx. Right? It means secant 2x tan 2x into dx, this will become dy by 2. So our integral I1 will become y square into dy divided by 2. So this 1 by 2 is constant. Integral of y square will be y cube by 3. So it will be y cube divided by 6 plus constant of integration. Okay, this will be our first integral. Similarly, if we do the second integral is integral of secant 2x tan 2x dx. We know the antiderivative of secant x tan x is secant x, so this will be secant 2x divided by derivative of the angle, that is 2 plus constant of integration. So therefore complete I is I1 minus I2, and when we substitute the values, we are getting here, what was the value of y? It was secant 2x. So we are getting 1 by 6 into secant cube of 2x minus 1 by 2 into secant of 2x plus constant of integration. This will be our answer. Right? So this is how sum number we have done 15. Sum number 15 will be done. It is not necessary that you have to follow the same way. If you can think of some other method, some other identity, some other way, definitely you people can do that, provided your steps are correct. And remember, since we are doing indefinite integral, there are chances if you go by a different method, answer may vary, because this is indefinite. So according to the substitution, according to the method used, answers can be different. It is perfectly okay. But the only thing is, whatever method we follow, whatever identities we use, those should be absolutely correct. Okay. Similarly, sum number 16, it is tan raised to power 4x. I am giving the hint for sum number 16. What we will do here, since it is tan raised to power 4x integral, right, we can write it as tan square x whole square, right? And now tan square x, we know it will be written as secant square x minus 1 whole square dx. When you expand it, the identity, you will be able to do the integration. Okay. And sum number 17 is very simple. When you are separating the terms, just it is like a plus b upon c form. So when you write down a upon c plus b upon c, you are getting your answer straightforward. Okay. Sum number 18 also I am leaving it for you people. Sum number 19 is, let us see how we will do sum number 19, because once you people understand that what is the concept and how to use the identities, then there will not be much problem in solving the sums. So I is given here in sum number 19, dx upon sin x into cos cube x. Okay. Now, 1 upon sin x, we know it is cosecant x, and 1 upon cos cube x. Now, 1 upon cos cube x means it can be like secant cube x, right? But what will happen here, what will be the answer here? We are not getting any straightforward thing if, right? So what we will do, again we will think of the identities, or we can multiply, divide also to make the function simple, right? Now the same thing if I do here, if I multiply and divide the denominator by cos, here I will get tan, and here if multiplication will give me cos raised to power 4x. Now cos raised to power 4x means secant raised to power 4x. Okay. So let us see what way we can go for this sum. So let us go with our idea that if I multiply and divide the denominator by cos, I am writing here multiply and divide the denominator by cos x. So when we multiply and divide, what we are getting here, sin x upon cos x, and this will become cos raised to power 4x dx. So this what we are getting, it will be tan x, and 1 upon cos raised to power 4x, I can write down secant power 4x in the numerator. So this secant power 4x, that means secant square x whole square into dx divided by, we are having here tan x. Now we know the relationship between tan x and secant square, that the derivative of tan is secant square, but we are getting square of this thing. And one more thing we know here, that secant square x can be written as 1 plus tan square x. So it means if I separate this secant square x into secant square x like that, and here denominator tan x is there, then this secant square x can be written as 1 plus tan square x, this divided by tan x, and into one term secant square x is left now. Okay. And now I think the sum has become very simple, because here also tan is there, and if I put tan as y, secant square x dx will become dy. So let us go for that. We will put tan x is equals to y, and when we differentiate both sides, we will get here secant square x dx equals to dy. So let us substitute this in the integral. So our integral will become 1 plus y square upon y into dy. By mistake I wrote t here. So it is 1 plus y square upon y plus into dy. So when we separate the terms, we are getting here 1 upon y plus y dy. We know the integral of 1 upon y, it is log y. Integral of y is y square by 2 plus constant of integration, and the value of y is tan x. So what we are getting, log of tan x, definitely modulus of tan x, plus tan square x by 2 plus constant of integration. So this will be our answer for sum number, this is 19th sum. Sum number 20 also, let me give you the hint how will you start the sum. We have cos 2x upon cos x plus sin x square. Now this cos 2x, the angle is x in the denominator, in the numerator angle is double. So we know the formula, it is cos square x minus sin square x divided by, what do we have, cos x plus sin x whole square, right? Now you people have to think of what I can do here. If I apply a square minus b square formula, one term will get cancelled and you will be left with cos x minus sin x upon cos x plus sin x. And we know the derivative of sine is cos, the derivative of cos is minus sine. It means if I apply the denominator as y, numerator will become its derivative. So you can do the sum easily. Sum number 21, sine inverse of cos x. Again you people have to sum number 21, let me tell you, it is sine inverse of cos x. Now we have outside, we have sine inverse, in the bracket we have cos, and if you remember we don't have any formula to integrate inverse, right, till now, till this exercise. So what we will do here, we have to simplify, and as we know how to simplify the functions in inverse trigo chapter, same thing we will do here. Cos x identity, if you remember, you apply the formula of cos 2a in terms of sine, right, so that you can cancel or you can simplify the function to do the integration. Try this sum. And sum number 22 also, 1 upon cos x minus a cos x minus b. Here also in the numerator 1 is there. So what we are going to do here, let me write down the statement, 1 upon cos x minus alpha into cos, okay, a is given, into cos x minus b dx, right? So here there are two constants a and b. What we will do here, in the numerator no function is given, so we have to bring one function in the numerator so that we can simplify the function to do the integration. Cos is there, so we know the derivative of cos is sine. So what we will do, we will bring sine function in the numerator, and for that if I have to bring something here, I have to multiply and divide. So what we will do here, we will multiply and divide by sine of, since a and b two constants are there, I am writing here a minus b, and here also we can write down sine of a minus b divided by cos x minus a into cos x minus b. Now sine a minus b is there, the denominator angle is x minus a x minus b, and we know in this if I add something and subtract also same thing, it will not make any difference. So what we will do, in the angle we will add x and subtract x so that we can have same kind of angle, and then we will apply the simple formula in the numerator to get the integral in the correct form. So let us continue here. What we are going to do, we will add and subtract x in the angle of sine function which is in the numerator. Outside we have 1 upon sine of a minus b, and here we are writing sine a minus b plus x minus x. Denominator we have cos of x minus a into cos of x minus b, right? Now the angle x minus a and x minus b, accordingly we will make the angles there. So for that, if you want, in the beginning itself we can take b minus a, but the question is how will we come to know b minus a we have to take or a minus b we have to take. So it is perfectly okay. I am going to write here first of all x minus a. Since a is positive, here I am taking negative sign, and then I need x minus b. So b is negative, one x is positive, so here we will be taking the plus sign, right? Whole divided by cos x minus a into cos x minus b dx. Now if you remember the formulas of sine a minus b, what is sine a minus b formula? Sine a cos b minus cos a sine b. So if we apply that formula, our sum or our integral will become very simple. So I am rewriting this thing first of all. This is x minus b minus x minus a whole divided by, there will be no change in the denominator function, cos of x minus b dx. Now here we will apply sine a minus b formula. This complete is a and this complete term is b. So let us apply the formula, and the sum is almost done once the formula is applied. Sine a minus b will be sine a cos b minus cos a into sine b, right? So here sine b means sine of x minus a whole divided by the same denominator cos x minus a into cos x minus b dx. Okay, in the next step what we will get, 1 upon sine of a minus b will remain as such integral. When we separate the terms, what will happen? Cos x minus b will get cancelled. Sine x minus b upon cos x minus b will be tan of x minus. Okay, here I think I have written a term will come na. By mistake I have written b, because sine a cos b. So cos and cos will get cancelled. Sine x minus b upon cos x minus b will be tan of x minus b minus. Now cos x minus b sine x minus a. Now cos x minus b and cos x minus b will get cancelled, and here we will get tan of x minus a dx. Now in the formulas of the exercise, if you remember, we in the antiderivatives we don't have the formula to integrate the function tan, right? But in the formulas of exercise 7.2 we have the formula to integrate tan. What is that? Log of mod secant x. So this 1 upon sine a minus b, which is constant outside, integral of tan x minus a, it will be log modulus of secant whatever angle is there. Here we have angle x minus b minus, this will be log mod secant x minus a and bracket closed plus constant of integration. And we know the formula log a minus log b, it is log a upon b. So we will get sine of a minus b into log of modulus secant x minus b upon secant of x minus a plus constant of integration. So this is how we will do the sum number 19 of exercise 7.3. Not 19, sorry, it is 22 number. Sum number 23 and 24, same way you people will be able to do. Just separate the terms, integrate in sum number 23, you are getting your answer. Now you people can complete exercise 7.3, which is based upon only in trigo identities, right? So with this the exercise is over. I hope you people can complete the exercise. Thank you, students.